Hello everyone. In this video I'm going to be looking at graphing complex numbers on a complex plane. In this case, I'm looking at 4 plus 3i, 7 minus 2i, and negative 3i. So three different points that I want to graph on the complex plane. Now, the complex plane is very much like your rectangular plane. It has, instead of an x and y axis, it has what's referred to as a real axis and an imaginary axis. If you recall, in the form a plus bi, a is referred to as the real part and b is referred to as the imaginary. So each of these we treat very much like an xy term. So 4 plus 3i you can think of as 4, 3, graphing the point 4, 3. So very much like xy coordinate, I'll go over 4 to the right, up 3, and there's my point. 7 minus 2i is the same as 7 and negative 2. So I go 7 to the right, down 2, and there it is. Negative 3i, since there's no a term, we assume it to be 0. Let's make that a 0. And then negative 3. So 0 to the right, and then negative 3 down, or 3 down I should say. And there we go. And there are 3 points. So this is again how we graph complex numbers on the complex plane. Now a slight variation of that is if we're asked to graph the form a plus bi, where a is greater than or equal to 4 and b is less than 2. So what this means is if I have a is greater than or equal to 4, a is my real value, it's on my real axis. So I'm going to find 4. There it is. And first of all, I'm going to draw a straight line because it's greater than or equal to. So I'll draw a vertical line. And vertical because it's on the x, well, what's the equivalent of the x-axis. Now, because it's greater than or equal to, we need to think which side corresponds to all values greater than or equal to 4, and that's going to be the right side. So over here. B is less than 2, B being on my vertical axis or my imaginary axis, I'll find 2. Now because it's less than but not equal to, this one will get a dashed line. And let me keep on going through there. Now if I'm talking about everything that's less than less than 2, that's going to be everything below here, including over there. Now the thing is, we only want the intersection of these two areas. So while individually this is how they would look, I want both of these, the overlapping sections. So the overlapping section would be everything less than 2, everything to the right of 4. And that's going to be this section over here. And let me... Actually, I'm just going to highlight it this way. That's going to be this section, everything to the right of 4, everything less than 2. So this would be the actual solution if I were to graph these, and these are referred to as inequalities. So the difference is, here I'm graphing specific points on a complex plane. Here I'm graphing inequalities on the complex plane.